Welcome to the presentation of Lab 1, which is about configuring routing in Omnet++. In this lab presentation, how the routing tables are generated automatically and also how we can manually override specific routes will be examined. So I want to start with the ini file and the general part. I'll start with the configured settings in here. So in the configured settings, dump address, we set this to true. It enables us logging of network addresses information such as IP addresses, assignments for each node in the network. And dump topology enables saving the network topology details in the network. It could be structure of nodes and their connections. And dump links enables us to log in detailed information about network links such as bandwidth, delay, link status, or etc. And the last one in the configurator settings is dump routes. It's also set to true. It enables us the logging of routing table entries for analyzing routing behavior such as network routing decisions used by devices. And routing settings. And we set the type name of ARP in the IPv4 configuration to global ARP. Why we done that? Because it will create one shared address resolution protocol table for all nodes. Instead of having separate ARP tables per node, this configuration leads us to have reduced overhead and speed up at the address resolution because of having one global ARP cache. So we done that because of some performance configurations and all the details mentioned in here. And other routing setting is netmax routes. It's set to empty because this ensures default network-based routing metrics in IPv4 are removed. This is also another necessary configuration. And visualization settings, display interface tables, enables demonstration of network interface tables, visualization for each node, such as MAC addresses and IP addresses. And node filter filters out nodes to exclude access points and switches from interface table visitation, access points and switches. And this is the general part of Omnet ini5. I want to mention the step 4 for starting. And it connects network to configurator A file. In here, network equal to configurator A. What is the configurator A.NET file? It defines the structure of our simulation design. And it is like sub-modules defined in here with their positions. As you can see in here, we have visualizer, switches, and hosts. And also we have some connections to design our simulations. We use Ethernet 100 megapixel cable. It will be important in the later simulations like step 6A, 6B, because they're configurators in XML files, but we will mention that later. So this is how the net file look. So let's continue with the step 4. And I want to mention the main purpose of step 4. In step 4, the routing arrangement is totally automatic, which means that Omnet++ constructs routing tables according to network topology, without requiring any manual user interactions. And also, in the step 4, the Omnet++.ini file specifies that host 1 executes a ping job, which transmits echo request, or in other words, pings, to host 7. And another detail to mention in step 4 is that the IPv4 configurator automatically manages the routing, guaranteeing that routes are established and used dynamically. This is the purpose of step 4. So let's examine each components also. Number ops assigned to 1. It will adjust number of ops of host 1 to 1. It will make host 1 to run only one application in the network. And type name of the application is pingjob. It assigned to pingjob to host 1. So I want to mention why we use pingjob instead of global app. Because for basic connectivity testing, pingjob is ideal because it is lightweight and effective. And for IMCP traffic, and on the other hand, global app is not required for this kind of simple task like pinging, and it is intended to simulate complicated application layer traffic such as bulk data transfers. So this is the reason why we choose pingjob instead of global app, because of the application. It is not complex, that much complex to use global app. It is not required in this application. And another thing is destination address assigned to host 7. because it will end up at the host 7. The main goal is reaching host 1 to host 7. We will see when we start the simulation. Some visualizer settings display routing tables. Routing tables are in the network, and another one is the destination filter assigned to host 7. It will filter the routing table visualization to only display routes leading to host 7. So let's start the simulation to see actually what happens. Let's start. In the simulation, it starts by host 1 sends signal to the switch 0. Then, what switch does is, it will emit the signal to host 0, host 2, and router 0, basically all the linked devices. Why switch behave like that? Because the destination MAC addresses of packets are examined by the switch, and in this case, like we faced in step 4, the switch does not already have a record for that MAC addresses, so the switch will broadcast the packet to all linked devices to learn patterns will be used in later. Then, router 0 will send the signal to router 2, which handled by the system automatically. In the INI file, we set the automatic configuration. Then, router 2 will send the switch 2, continue. Then the same behavior done by the switch 2, it will emit the signal to all linked devices. Then the host 7 will reply and send signal. Because we set the destination address as host 7, so host 7 will be the replier for that packet. Then switch 2 will be route to router 2, then router 0. Then switch 0 will be automatically route to host 1 without emitting the signal to all linked devices because it learned the MAC addresses before, so it will not do the same behavior again. Then simulation will continue like that. So let's continue with the step 5a. Step 5a introduces us manually overriding individual routes to specific host, in other words, single host. In later, we are going to cover how to route the set of hosts in step 5b, but now our focus is on how to route specific host. So let's start explaining the main differences from before. Step 5a, instead of depending on automatic routing decisions, we set up manual route for host 0 to reach host 7 via certain pathways. This is accomplished by editing the step file XML file and manually defining the route settings. We will examine the XML file later in this project presentation. So let's start. First, step 5a extends all settings from step 4 that we defined earlier. Then, it makes configuration by XML file, and basically it loads custom-defined XML file, which is step 5a XML, to be able to make routing configurations manually. We will explore. Then, similar configuration down, number of hops to 1, and type name as PNG. The difference is, in here, we assign start time to 0.6 seconds. It will specify the start time of PNG to 0.6 seconds after the simulation begins. We will see in the simulation what this specification actually does in later. So let's cover XML file. In XML file, we set the destination to 10.0.35, which is host 7 actually. And also, we set gateway to router 1 in this specific address. We will see the effect of it later, but important thing is destination set to one specific host manually. Okay, so let's start the simulation. So let's continue with the simulation to understand the effect of the manually configured XML file in the simulation routing mechanism and also host destination. So let's start. Firstly, host 1 will send the packet to switch 0 as before. It will emit the signal to all hosts. Then, what we done is router 0 will send the packet to router 1. Why it does that? Because we define gateway as 10.0.018 in XML file, which is this specific gateway number in here. So this results in routing router 0 to router 1. So let's continue. It will go to router 2 and to switch 2. Then it will go all the hosts as before. But then, as we can see, host 7 will send the packet to switch 2. Why host 7 did the sending? Because we manually configure the destination address in the XML file by this specific number 10.0.035 as a destination address. So we manually configure one destination address in the XML file. Then once it completes a complete cycle, it will end up learning the pattern. So it will never go through again router 1 because it learned the pattern. The simulation will continue like that. So as a result, we learned step 5a how XML file help us to manually configure routing decisions, also destination address, and this end up giving us greater control over how traffic is routed to specific destinations via the configurations we did in XML file. So let's continue with the step 5b. Step 5b expands the manual routing approach by allowing us to create routes to many hosts. And this is handled via specific configurations done in a different custom XML file named step5b.xml. Only difference from step 5a is XML file configurations. Other things is same from step 5a. So let's cover XML file. In XML file, configurations step 5b adds is that it makes the destination address as this specific number with a net mask of this number, which designates the addresses of host 6 to host 8, which is a set of hosts that we want to route manually. So this configuration allows us to have more complex routing configurations that target multiple destinations by changing the netmask and destination. So let's see the simulation to see the results. So let's start the simulation to see the effect of the XML file configurations, like changing netmask to a specific number, which indicates the hosts 6, 7, and 8, and also destination address like 10.0.032, which is this number. And also the same configurations also exist in the step 5b, like gateway is equal to 10.0018. It will also route router 0 to router 1. This is the same as 5a. So let's start. Once it goes through these addresses, host 7 will reply. In the second cycle, host 6 will reply because we set manual destination addresses as between these hosts. It can go through host 6 or host 7 or host 8. We configure it like that in the XML file manually. And I want to explain generally what this does. This step 5b is important for directing traffic to multiple destinations and manually controlling how traffic flows across multiple network nodes. This is what we done in this simulation. In step 6a, it introduces us setting different metric for automatic routing table configuration using data rate metrics. What this means is step 6a concentrates on selecting routes based on link performance, specifically data rates, rather than utilizing default metrics or explicitly setting routes. This phase enables the network to automatically select paths based on link speed. In other words, higher data rate paths are preferred. And we are doing that by manual configurations done in XML file. And rather than the XML file configurations, one other difference made in this step 6a, which is we don't add pinjab because our focus is on routing decisions, not application layer testing. Because of this reason, we don't add pinjab. Other than that, let's cover XML file. In XML file, difference is there is an element named autorate with a metric data rate. Autorate will configure us to select shortest path, but by defined metric. In here, we define data rate to choose shortest path by using data rate metric in here. These configurations done like that. So let's start the simulation to see the effect of it. So let the simulation begin to see how the routes are chosen based on link speed. So let's start the simulation. It looks similar to configurations we made in the step 5, but right now it chooses paths based on data rate. And another thing that I want to mention is changes made in this step does not require any modification in the application behavior, and the pinjab still operates. But instead of using static or manually set routes, routing decisions are now based on data rate. This is what we achieve in step 6.8. And as a result, by modifying routing decisions based on a data rate, the system optimizes network performance and ensures that high-speed paths are selected. So let's start the last one, which is step 6b. It introduces us setting different metric for automatic routing table configuration, manually specifying link cost. I will explain how it does in XML documentation. So let's start looking for settings. It does not have any different setting except XML file from step 6a. It also does not have pin job, and also, in other words, host 0 does not need to run a pin job in this arrangement. The primary focus is on routing tables and the cost of each route. So let's start looking at XML file, step 6b. This XML file specifies the manual link cost to influence routing decisions. How it does is XML file specifies the metric to be hop count and sets the cost of router 0's Ethernet to interface to infinite cost in here. And at the end, this affects the link between router 0 and router 2, as no routes should go through it, as it writes in documentation. There will be no routes going from router 0 to router 2. So let's start the simulation to see the actual results. So let's start the step 6b to see the effect of changes we made in the XML file, like changing path cost between router 0 and router 2 to infinite cost. And this will result as no routing will be done between router 0 and router 2 because of the infinite cost. So let's start the simulation to see the results. As we assume, there is no routing between these two routers because of the cost, and the routing will follow like that. As a result, the difference between step 6a is we manually configure routing rather than making system automatically choose best path according to data rate or link speed. We manually configure it, and this provides us more control over system. This is what we achieve. As a result of this presentation, on .NET++ and the iNet frameworks, several routing setups were discussed in this tutorial. We look at the ways to manage and customize routing decisions, starting with fully automatic routing in step 4, as we discussed before in here, and moving on to manual routing overrides in step 5a and step 5b to specific host to set of host, and data rate based and manual link cost routings in step 6a and step 6b. All the differences comes from changes made in XML documentation, except step 4. There is no XML file located in step 4. And lastly, we examined how routers determine the optimal path for packets to go and tested connectivity using the pin job. This is the end of the presentation.